So guys, this is the continuation of our problem solving applying differential equation. So here I got another problem. So a metal ball at temperature 100 degrees Celsius is placed in a tank of negligible heat capacity containing water at 40 degrees Celsius. The tank is perfectly insulated so that no heat is lost from the system, and the only transfer of heat is that from the ball to the water. After 15 minutes, it is observed that the ball temperature is decreasing at 80 degrees Celsius. Assuming that the temperature of the ball at any instant is the same at all points, find the temperature of the ball as function of time. When will be the temperature of the ball be 75 degrees Celsius? So here guys, we have a formula. It is from Newton law of cooling. So here, as you can see, this formula here, we can use variable separable by this will be transferred here, and this will be transferred here. So it is integration of dt. Capital T is a body temperature or system temperature over T, and T of M is equals to the integral of dt in terms of K. So here we got E ln of T minus Tm. So this is E KT plus C. See you guys, if you notice that this, if we let you integral of dt u, so this is du actually, so I forgot, let u is equals to t minus tm, and dt du is simply dt. So here we got ln of u or equals to ln of t minus tm. So this is has absolute value. So proceed here, we multiplied e both sides so that we can get rid of this ln, and we have t minus tm is equals to, this will become c e k t, and you can transpose this this one, so we got t is equals to c e k t plus tm. So this is our equation now. So in the problem, it says that at the problem that at time is equals to 0, the temperature is 100 and the medium temperature is 40. So at time is equals to 0, the T is 100 degrees Celsius, and our TM guys is the temperature of the medium, which is the water, is 40 degrees Celsius. So here we can input this into this to solve for the value of C. So to the value of C is equals to this is 100 is equals to C E, and guys, if you multiply this, K is equals to 0, it simply is equals to 0 plus 40, so this will become 1. So we have C is equals to 60 degrees. So we solve the C. So now it says that at time which is 15 minutes, the temperature is 80 degrees Celsius and the temperature of the medium is 50 degrees Celsius. So we input this into 80 degrees is equals to our value of C is 60 e raised to the power of K and T, which is 15 minutes, plus the value of this will be 50. So K will be, by the use of scientific calculator, we can solve for the K. So simply 80 is equals to 60, and this is X 15 plus 50. We can solve for the value of K. Shift solve. So our K here is negative 0.0462. This is the value of our K. So here, this problem, it says that assuming that the temperature of the ball at any instant is the same at all points, find the temperature of the ball as function of time. When will be the temperature of the ball become 75 degrees Celsius? So the problem here is the time. So how do we solve the time? So according to Newton's law of cooling, so the rate at which the temperature of the body changes is proportional to the difference between the instantaneous temperature of the body and the temperature of the surroundings medium. If a body whose temperature is initially 100 degrees Celsius is allowed to cool in air which remains at constant temperature at 20. So at our problem is a metal ball at temperature 100 degrees Celsius is placed in a tank of negligible heat capacity containing water at 40 degrees Celsius. So the value of our temperature here, 100, is equals to constant temperature of 40 degrees Celsius plus the temperature of the medium. Simply we can get temperature of the medium is equals to 60 degrees Celsius. So here we can find the temperature of the ball as function of time. It will become T is equals to 40 E KT plus the medium temperature, which is 60 degrees Celsius. So for the follow-up question, when will be the temperature of the ball be at 75 degrees? So replace this T as 75 degrees is equals to 40 E. We all know that the value of this K is simply negative 0.0462. So we find that T plus 60 degrees. So T in terms of minute, we can solve this. So we can solve this by simply inputting this in our scientific calculator. 75 4E raised to the power of negative 0.0462 times x plus 60. If solved, we have a value of 21.23 minutes. So the temperature of the ball will be at 75 degrees Celsius in the time of 21.23 minutes.